The milk in your refrigerator is not milk, not in the way the animal made it, not in the way it left the cow. By the time it reaches the shelf, it has been spun, heated, stripped, and rebuilt. And the industry that did that to it knew exactly what they were removing and exactly what they were putting back. And almost none of it is on the label. Two things are happening simultaneously inside that story. The first is what pasteurization, homogenization, and fortification actually do to the physical structure of milk. What they remove, what they alter, and what they replace. The second is who decided each of those steps should happen, when, and why, and whether the reason given to the public was ever the real reason. Those two lines run together, because they were never separate. Start with the fat. Raw milk separates, the cream rises. That is not a defect, that is what milk does. For most of human history, that separation was the point. You skimmed the cream, you used the skim, or you drank the whole thing and shook it first. Then, in the 1940s and 50s, something changed. Dairy processors began rolling out homogenization at industrial scale, a process where raw milk is forced through an extremely narrow valve at high pressure, somewhere between 100 and 2,500 pounds per square inch, which physically shatters the fat globules into particles so small they cannot recombine and rise. The fat becomes permanently suspended throughout the liquid. It does not separate. It looks uniform, it photographs well, it ships without visual inconsistency. And here's the thing nobody told you about that process. Homogenization does not add anything. It does not remove anything. What it does is change the structure of everything that was already there. Fat globules that were naturally coated in a membrane that influenced how your digestive system processed them, are now shattered and exposed. The membrane is gone. The particle size is radically smaller, and the research into what that structural change means for the human body is complicated, not settled, not loudly discussed by the industry. Some researchers have raised questions about oxidized fats and cardiovascular exposure. Others point to changes in how fat-soluble vitamins behave in a homogenized matrix. The dairy industry's position has been, consistently, that homogenization is a processing step with no nutritional consequence. That position has been commercially useful. Whether it is entirely accurate is a different question, and it remains open. But here is where it gets darker. Because homogenization was not primarily a health decision, it was a logistics decision. Uniform milk does not separate in the bottle, does not develop visible cream lines that different distributors in different regions might have in different ratios, inconsistencies that created consumer complaints and brand perception problems. Homogenization solved a visual and logistical problem. The justification offered publicly was convenience and consistency. What it also did was make it impossible for the consumer to see what they were getting, because a glass of milk that looks the same from every bottle in every region, from every cow, regardless of actual fat content or quality, that glass of milk becomes very easy to standardize downward without anyone noticing. Then comes pasteurization. And this one is more complicated, because pasteurization, unlike homogenization, has a genuine public health foundation. Louis Pasteur's work on heat and bacterial contamination in the 1860s was real science. Tuberculosis was real. Brucellosis was real. The diseases that moved through raw milk in the early 20th century were killing people, and pasteurization dramatically reduced that. That part of the story is true. What is less discussed is what pasteurization also does to the milk itself. Heat denatures proteins. The specific temperatures used in standard pasteurization, around 72 degrees Celsius for 15 seconds in the most common commercial process, destroy a significant portion of the native enzymes in milk, alkaline phosphatase, lipase, lactoperoxidase. These are not trivial. Alkaline phosphatase plays a role in phosphate absorption. Lipase helps break down the fat. Lactoperoxidase has documented antimicrobial properties. The heat kills them. And the industry's consistent response to this has been, it does not matter. The enzymes are denatured in digestion anyway. The body does not need them from the milk. That argument may be partially correct, but it is also an argument that has never been fully resolved, and the industry has not been particularly eager to resolve it because the alternative to pasteurization at industrial scale does not exist. The volumes are too large. The supply chain is too long. You cannot ship raw milk across thousands of kilometers and maintain any margin of safety. So the enzymes go, the process continues, and then comes the rebuild. Vitamin D is not naturally in milk in significant amounts to begin with. A cow grazing outside gets sunlight exposure and produces some vitamin D in its skin, the same way humans do. But a cow in a commercial dairy operation indoors, under artificial light, producing 10,000 liters per year, that cow has minimal circulating vitamin D. The raw milk already has almost none. And then the skimming process removes most of what fat-soluble vitamin content existed. So the dairy industry adds synthetic vitamin D. specifically vitamin D3 in most countries, produced from lanolin and sheep's wool, directly into the milk before packaging. And then they market the result as a natural source of vitamin D. The vitamin that is in your milk is not from the cow. It was not in the milk when it left the cow. It was added in a processing facility, sourced from a different animal entirely, and listed on the label in a way that suggests it was always there. Vitamin A gets added back the same way as synthetic retinol palmitate in most low-fat and skim milk products, because the natural vitamin A left with the fat. Whole milk retains more of it, which is one of the more ironic turns in a story full of them. The product the industry spent decades telling people to avoid for cardiovascular reasons is the product that was never stripped of the things it naturally contained. If you enjoy understanding how the world actually works beneath the surface, subscribe. It is the best way to support this work. Drop in the comments what city or country you're watching from. This script is deeply researched using data from the Food and Agriculture Organization of the United Nations and peer-reviewed work published in the Journal of Dairy Science. Now back to it. But it does not stop at vitamins, because there is a larger category of what gets added to commercial milk that moves well past nutritional rebuilding and into something that starts to look like formulation. Milk solids, non-fat dry milk powder. These are added, legally in most markets, to fluid milk products to adjust protein content, improve texture, and extend shelf stability. Non-fat dry milk is produced by evaporating fluid skim milk down to a powder. It is the concentrated, dried residue of the thing that was already processed. And it gets added back to some fluid milk products to bring protein numbers up, to thicken the mouthfeel of products that have had fat removed, and to reduce visible separation or inconsistency. In many countries, this addition does not require explicit label disclosure if the product is still labeled as milk, because it is technically milk-derived. You are drinking milk that has had things removed and then had powdered milk added back to compensate. The label says milk. Then there are the stabilizers. Carrageenan, derived from red seaweed, is added to flavored milk products, to chocolate milk, to some cream products, to maintain texture and prevent separation. It is on the ingredient list if you look. Most people do not look. The scientific debate around carrageenan's effect on gut inflammation has been ongoing for decades, with some animal studies raising concerns, and the food industry consistently maintaining that the form used in food products is safe. That debate has not been resolved. Carrageenan continues to be used. Standardization is the word the industry uses for what might be the most invisible process of all. Every batch of milk that comes in from different farms, different cows, different seasons, different feed regimens, has a different natural fat percentage. A Holstein, in peak summer lactation, producing milk at 3.2% fat, is giving you a biologically different product than a Jersey in late winter, producing at 5.2%. The industry solution to this variability is to blend, separate, and recombine milk to hit a precise target fat percentage, 3.25% for whole milk in the United States, for instance, as set by federal standard. The fat is literally removed and then added back in measured amounts to ensure every bottle of whole milk in the country has an identical fat percentage, regardless of what the actual animals produced. Now for the things held back until now. Because some of what happens before the milk reaches you is less well known than pasteurization and homogenization, and it lands harder once you understand the system it sits inside. The first is what happens to ultra-pasteurized milk, the kind in the extended shelf life cartons, sometimes called UHT, or ultra-high temperature processed. Standard pasteurization heats milk to 72 degrees Celsius for 15 seconds. UHT processing heats milk to 135 degrees Celsius for 2 to 5 seconds. That temperature does not just kill pathogens, it fundamentally alters the protein structure of the milk in ways that change flavor, texture, and digestibility. The slightly cooked or flat taste associated with UHT milk is not a packaging artifact. It is the result of the Maillard reaction occurring between the milk proteins and sugars at that temperature. The milk has literally browned chemically in a fraction of a second, invisibly, before being sealed in the carton. UHT milk can sit unrefrigerated for 6 to 9 months. The reason it can do that is the same reason it does not taste like fresh milk. The two things are inseparable. The second, synthetic flavor. Whole milk tastes the way it does, partly because of naturally occurring diacetyl and other volatile compounds produced by the fat content and bacterial culture history of the milk. When fat is removed and added back at standardized levels, and when the milk has been heat treated to kill native bacterial cultures, that flavor profile changes. Some processors add back trace synthetic diacetyl, the same compound that gives butter its flavor, to restore what the process removed. It is listed as natural flavor on the label. It is a compound that was synthesized or isolated in a facility and added to replicate what the original product contained before processing. Natural flavor means something very specific legally, and it means something very different in common language. The third, the mastitis reality. At any given point, the measurable percentage of commercial dairy cows globally are experiencing mastitis, a bacterial infection of the udder, which is the direct result of the biological pressure of continuous, high-volume production. The animal was bred and managed to produce volumes of milk that put extreme stress on the mammary system. Mastitis is the most common disease in commercial dairy operations worldwide, according to data from the International Dairy Federation. Milk from cows actively being treated with antibiotics is supposed to be withheld from the commercial supply, and testing protocols exist to detect residues. But the somatic cell count, a measure of white blood cells in the milk, which rises when the animal's immune system is fighting infection, is the real indicator. Regulatory thresholds for somatic cell counts vary significantly by country. The EU allows up to 400,000 cells per milliliter. The US allows up to 750,000. That milk, within legal limits, is pooled with all other milk, pasteurized and packaged. The count is not on the label. The fourth, the hormone question. Recombinant bovine somatotropin, RBST, is a synthetic growth hormone that directly increases milk production in dairy cows by extending the length and peak of the lactation cycle. It was approved for use in the United States in 1993. It is banned in the European Union, Canada, Australia, and many other markets. In the US, its use is widespread, though not universal, and milk from RBST-treated cows is not required to be labeled as such unless the producer specifically claims to be RBST-free. The FDA's position is that milk from treated cows is indistinguishable from milk from untreated cows. Independent researchers have raised questions about elevated insulin-like growth factor levels in milk from treated animals and the implications for human cell growth signaling. That scientific conversation remains open. The commercial conversation was settled in 1993. What the cow was designed to produce and what the industry decided to do with the cow were never the same project. The breeding programs that took dairy cattle from 800 liters per year to over 10,000 pushed the animal past any biological equilibrium it evolved to maintain. The processing systems that followed exist because milk produced at that volume and that speed cannot survive in its original state. It spoils too fast. It separates in ways that are visually inconsistent. It varies in fat content by farm and season and individual animal. And so it gets spun, heated, stripped, reconstituted, standardized, and fortified, and the result is packaged in a carton with a pastoral image and sold as the simplest, most natural product in the store. If this changed how you see something you thought you already understood, subscribe. Every video goes this deep. We will see you in the next one. The label says milk. The vitamin D inside it came from sheep's wool. The vitamin A was added back after the process removed it. The fat percentage was set by a federal regulation written in the 1950s. The taste you associate with freshness was engineered after the original taste was cooked away, and the cow that started all of it has never been further from the animal on the carton. There is one more layer underneath all of this that almost never gets discussed, and it is the layer that connects everything else. The global dairy industry is not a collection of farms. It is a supply chain architecture built around 3 or 4 commodity inputs that get assembled into a product and called something it no longer entirely is. And the companies that sit at the top of that architecture, the processors, the cooperatives, the multinational distributors, are not primarily in the business of delivering nutrition. They are in the business of managing margin across a perishable commodity at planetary scale. Those are not the same business, and the difference between them is visible in every decision that was made about what to remove from milk and what to put back. Consider what fortification actually signals. When an industry adds things back to a product, that is not evidence of generosity. It is evidence of a process aggressive enough to require compensation. You do not add synthetic vitamin D to milk because you care deeply about bone density. You add it because the process you ran stripped the product of enough value that the regulatory environment, or the marketing environment, required you to replace something. The fortification is the admission. Every added vitamin on that label is a record of what the processing took out. And the regulatory frameworks that govern all of this were not built around the consumer. They were built around the industry's ability to operate at scale, the somatic cell count thresholds, the limits that determine how much evidence of infection is acceptable in milk before it cannot be sold, were not set by asking what level is ideal for the person drinking it. They were set by asking what level the industry could realistically achieve, given the biological reality of high-volume dairy production. The threshold is a negotiation between what is commercially possible and what is publicly acceptable, not between what is present and what is safe. The same logic runs through the RBST approval. The FDA's conclusion that treated and untreated milk are compositionally indistinguishable was based on the testing methods available in 1993. The question of whether those methods were sufficiently sensitive, or whether the right markers were being tested at all, was not a question the approval process was structured to answer thoroughly. The approval moved forward. 32 years later, the scientific literature on insulin-like growth factor and long-term human exposure is still not closed. The product is still on shelves without a label. What you're holding when you pick up that carton is the output of a century of industrial decisions, each one made at a specific moment by a specific set of actors for specific commercial or logistical reasons, and each one absorbed so completely into the background of the food system that it stopped being visible. The pasteurization became standard. The homogenization became standard. The fortification became standard. The standardization became standard. And the product that came out the other end of all those standards got called natural. The cow on the label is standing in a field. She has never seen that field.